Hello everybody, welcome. And today we're going to use synthetic division to find the zeros of the polynomial function. So here we have our polynomial function 3x squared plus 5 minus 2 equals 0. So for this function, our divisor would our divisor would be x plus 2. So for synthetic division, we will be using this table. So basically, to fill up this table, you will need to add the numbers from your polynomial equation. In this case, ours is 3, 5, and negative 2. Make sure you don't forget the negatives, such as this one, as it will cause you to make mistakes during synthetic division. Alright, so our divisor here would be x2. Since we are dividing, we all know that the positive 2 will then turn to a negative. So now that we have set up our table here, I'll explain what we're going to do. So basically here, what happens is that the number will drop down here. So we're going to drop down 3. And so basically for every number that is here at the bottom will be multiplied by the divisor, which is negative 2. Which gives us which will then give us the product of negative 6. So what we're going to do is we're going to divide like normal. We're going to subtract from normal. So 5 minus 6 would equal negative 1. So again, we repeat negative 1 is negative 2 equals 2. So we're going to subtract again like normal. Negative 2 plus 2 equals 0. So we have found a 0 in in using synthetic division. The final row of the synthetic division shows the coefficients of the resulting linear equation, which is this. This is our equation. In this case, would equal 3x minus 1, which can which means that which oh no, oh no, it's flying. Which means that our equation, which means that our equation 3x squared plus 5x minus 2 equals 0 could be can be simplified into the following, which is parentheses x plus 2 and 3x minus 1 equals 0. So in this example, what we basically did is we divided the polynomial by x plus 2 to find the clear x value for synthetic division. The value used at the divisor is negative 2, which is a root of the equation. All right, so now we're back with our second equation, which is graphing a general equation. So we have g x equals negative x cubed plus 1/2 x minus 7. So when graphing the general equation, we're going to look at the we are going to look at the degree and leading coefficient. So the degree is usually the little number up here, which in this case it's a 3, meaning that the equation is cubic. We also know that our leading coefficient, uh, no, we also know since it is a cubic, it has a maximum of 3 roots, which means it could intercept the axis a maximum of 3 times. But it doesn't necessarily have to have contact with the axis 3 times. It's just a maximum amount. So let's say we could have, oh, I should probably change the color. Okay, change it to yellow. Alright, so here are some examples. Give 3 examples. So, by what they mean cubic is that it could touch the axis 3 points, or it doesn't have to touch at all. It just means, you can have a maximum to 3 points. So, it could go like this, like this, or like this. You see how this one doesn't touch, the turning points don't touch the x-axis at all, while these two do. So we can count it 1, 2, 3, 1, 2, 3. Well, this one only has one contact. Alright. So we also need to look at the leading coefficient. So over here, our leading coefficient for this equation is negative 7. So that would be so it'd be written like this. And that is a point of contact on the y-axis. So y-intercept is the point where the graph intercepts the y-axis. In this case, the intercept is 0, negative 7, meaning